So we are getting ready to start one of my favorite sections of the entire year. This is the meat of algebra. You are about to learn where all these letters and everything comes from. It's not that hard, but there are little tiny details that you really need to pay attention to. So, chapter 5, lesson 5, if you need to look anything up in your book. The official title for this is called Simplifying Expressions. Remember, expressions do not have equal signs, but we like to call it combining like terms, and I'll talk about what that means in a minute. So, first of all, some vocabulary. You need to be very, very comfortable with what each of these things are. Some of it is new, some of it is not new. We've talked about it a little bit already this year. The first one is a term, and that is a part of an expression, usually separated by plus and minus signs. That's where you can find them. I call the plus and minus signs the linkers. So in my example here, 3x plus 6y minus 2, there are actually three terms because this is a chunk, this is a chunk, and a good habit is to circle the negative with it. That is a chunk, and I'll tell you more about that in a moment. All right, so there are three terms in that expression. Now, more specifically, we've got like terms, and those are chunks that have the exact same variable and the exact same exponent. I call them identical twins. Not just siblings, but identical matches. All right, so three examples. 3x plus 4x, those are like terms because they both have the variable x and nothing with the exponent. It's a 1, but we don't write that. My second example, they are not like terms because even though we have x's, this one has an exponent of 2 and this one does not. So those are not like terms. And if I use my twins example, these would be twins. These would just be siblings because they're not exactly the same. They're close. They're the same family, but they're not exactly the same. The number in front has nothing to do with being like terms or not being like terms. For this, we're only looking at the variables. Then we get to my last example, 3m plus 4c plus 3. There is absolutely nothing about this that's the same. So that is as simple as it can go. I cannot combine any of these terms because nothing's the same. All right, a constant is a term without a variable. It's a number only. So if I go back to my last example up here, the 3 at the tail end is a constant. Now, if you go to the word variable, vary means to change. So this can change and this can change. But the word constant means that it stays the same. It does not change. 3 will always be 3. This will not change. It is constant, where this can change or vary depending on what C equals. And then the last one, this I know we've talked about already this year, is the coefficient. And I underline the prefix co. That means together, right? If you've got co-captains on a team or co-presidents, they do it together. A co-pilot. So a coefficient is the number that goes together with the variable. In the 6x case, the coefficient would be 6, just the number. In 12y squared, the coefficient would be 12. And in J, it looks like there's nothing there, but there really is a 1. Remember, mathematicians are lazy. We don't want to write more than we have to. So when there's a 1, a lot of times we leave it off. We talked about this a little bit earlier in the year. The coefficient there would be 1. You can certainly write it in. There's nothing wrong with it. If you're comfortable and want to leave it off, that's okay too. All right, let's talk about some examples for simplifying or combining like terms. So the first problem here is 4y plus y. You first have to ask yourself, do I have like terms? Well, yeah, y and y, same variable, same exponent. Now, to be able to combine these, you're going to combine the numbers in front, the coefficients. So what is 4 plus 1? 5. The y stays exactly as it is. That, 5y, is my final simplified answer. Now, let me give you a picture of what this looks like and why the y won't change. Let's say that I have some blocks, and I happen to have 4 of them, and they're all labeled y. And then I have one more exactly like it. Go back to elementary school. I've got a pile of 4 and a pile of 1, and they're all the same thing. When I push them together, I get 5 of the same thing. I get 5 y's. Now, keep that in mind because when I go to the second example, I've got another picture I have to draw you. For number 2, 7x minus 2 minus 7x plus 6. Do I have like terms? Yes. Now, if you are a lover of office products, markers, colored pencils, whatever, this is a perfect time to use them. If you are not a lover of office products, one single pencil will do the trick. All right. So you can mark them off with shapes. Anything that's an X, I'm going to circle. Now, a good habit is to take the sign in front of it, and I'll show you why in a minute. Okay. So all of my X's I did with a circle. I also happen to do them with the green marker. Colors, shapes, whatever you want to do. Now, I'm going to go through and I see that I've got some constants. I'm going to mark them either in a different color or a different shape. And again, I'm taking the sign in front of it because it makes life so much easier. All right. Now we're going to combine them. I don't care whether it says add or subtract. I'm going to combine them. Think like a little kid and push your piles together. Okay. Now I have to draw terrible drawings. I'm sorry. 1, 2, 3, 4, 5, 6, 7. Hey, look, there's 7 X's, right? It says 7X. Now take away those 7 X's. 1, 2, 3, 4, 5, 6, 7. I have no X's left. All right, let's go to my my constants. 1, 2, 3, 4, 5, 6. See, I switched colors because I'm a terrible drawer. You don't want to see what this would look like if I had to draw it. So there are 6 of those. But now it says take away 2 of them. What's left? 4. That's the answer to the problem. Now, if you're not an artsy person and you can't be bothered to draw these out, do it with the math. No big deal. Put my green stuff together. What's 7 minus 7? 0. So I have 0x. What's negative 2 and positive 6? Well, they're different, so I subtract. This one had the bigger pile, so it's positive 4. There you go. Now, if you really wanted to write 0x plus 4, you could. But again, mathematicians are lazy. Why am I going to write something that's not there? That's like me saying, oh, I have $10 plus 0 plus 0 plus 0. No, nobody does that. They just say I have $10. Okay? So we want to make this as simple as we can. If there's nothing there, don't worry about it. Okay, one like we had for these first examples, 7z minus z. Remember there's a 1 here. Are they like terms? Yeah. Now, if you're in the habit of circling, that's a good thing to do. You could also, for this one, just say, what's 7 minus 1? So for this one, it would be 6z. Okay, let's look at number 4. Do I have like terms? Yes. So I'm going to circle my ends. Again, take the sign in front of it. It's a good habit to get into. And then I still have this 6 kind of hanging out over here. Now, notice for all these, I'm not saying we're adding or we're subtracting, we're combining. If you take that sign in front of it, I promise it's easier than trying to figure out if you're adding or subtracting or, oh my goodness, what are we doing? We're just combining piles. Here I have 3 things called n, and I'm going to take 3 of them away. So what's 3 minus 3? 0, so I have 0 n's. And then I have this positive 6. So my answer is just 6. Now, if you really wanted to say 0n plus 6, I guess you could, but what? Now, keep it simple. All right, this last one. Do I have like terms? Yes, I do. I got some G's, got some more G's. I have some constants and some constants. Now, if you had more things, if you had extra letters or something like that, like let's say you had G and R and Q, you could just do different shapes. You've got triangle, you've got square, you've got circle, you've got squiggle bubble cloud thing. You figure lots of things to do. So let's combine these. I have 2 and negative 8. Well, what's 2 and negative 8 together? This one's going to be bigger, so I know my answer is going to be negative. They're different signs, so 8 minus 2 is 6. This is negative 6g. Then I'm going to combine my constants. I've got a -3 and a -11. This pile's bigger, so I know it's going to be a positive answer. Subtract these two. 11 minus 3 is 8. There's my answer. If you think about these as positives and negatives and not adding and subtracting, the signs will actually do the work for you, right? We said this was positive. If I had to read this entire expression, I would say -6g plus 8. Done. And some of you are going, well, why didn't you put those two together? Because they're not like terms. This has a variable. This does not. They're not identical twins. They can't go together. So this is my final answer. Now, a couple other things about this. Often, it's not required, but often the thing with the variable will come first. If someone were to write 8 minus 6g, that's actually an equivalent expression. But usually, we put the letter thing first and the constants after it. If you had more than one letter, like let's say you had 4a minus 6b plus 3, usually they go in alphabetical order. Also, if you've got exponents, let's say 4x squared minus 6x plus 9, usually the exponents go in decreasing order. So this is 2, this is 1, and then this doesn't have any at all. Okay, this is not a requirement, but if we all kind of do the same thing, it makes checking and comparing work way faster. There are lots of little details. We will talk about this for 3 days. Yes, today, tomorrow, and the next day. We will do so much practice with this, and you will be amazing at combining like terms when we're done.